आज हम स्टार्ट करेंगे कंप्यूटर ऑर्गेनाइजेशन पढ़ना। तो इसमें 4 ब्लॉक है और चारों ब्लॉक में 4 यूनिट है। तो हम स्टार्ट करते हैं ब्लॉक 1 का यूनिट 1 से और देखते हैं कितना कंप्लीट हो पाता है। अभी टारगेट है कि ब्लॉक 1 पूरा कंप्लीट करें। लेट्स सी कि कितना कर पाते हैं। और एग्ज़ाम के लिए समय काफ़ी कम है, तो अभी मैं ये कंप्लीट पूरा कर लूँगी। उसके बाद फिर मुझे MCS 201 का भी प्रिपरेशन करना बाकी है। तो चलिए स्टार्ट करते हैं। यहाँ पे हम रखे हुए हैं उसका पूरा टेक्निकल वर्ड में नहीं है, थोड़ा इजीएस्ट वे में यहाँ पे हम रखे हुए हैं। तो पहले ये पढ़ेंगे तो ही समझ में आएगा। पूरा प्रोग्रामेटिकली और पूरा टेक्निकल वर्ड से इतने ज़्यादा रिलेट नहीं कर पाएंगे, इसलिए। तो पहले देख लेते हैं कि ब्लॉक 1, यस ये ब्लॉक 1 ही है। यस, ब्लॉक 1 का यूनिट 1 कंप्यूटर सिस्टम है, डाटा रिप्रेजेंटेशन है, लॉजिक सर्किट्स एंड लॉजिक सर्किट्स का सिक्वेंशियल सर्किट्स है, राइट। तो डेटा रिप्रेजेंटेशन में बाइनरी, डेसिमल, ऑक्टल, हेक्साडेसिमल, ये इससे रिलेटेड नंबर सिस्टम से रिलेटेड क्वेश्चन होंगे। तो यूनिट 2 को हम स्किप करेंगे एंड आगे बढ़ते हैं। यूनिट 1 से यूनिट 1, हाँ, यूनिट 1 में क्या कंप्यूटर सिस्टम से रिलेटेड है। इंट्रोडक्शन, ऑब्जेक्टिव, ब्रीफ इंट्रोडक्शन, CPU, रजिस्टर, सेट्स, डेटा पाथ, कंट्रोल यूनिट, मेमोरी यूनिट, IO, एंड व्हाट इज इंस्ट्रक्शन एग्जीक्यूटेड, इंस्ट्रक्शन साइकिल, वेरियस कंप्यूटर आर्किटेक्चर, वॉन न्यूमन आर्किटेक्चर, हार्डवर्ड आर्किटेक्चर, इंस्ट्रक्शन सेट आर्किटेक्चर, रिस्क, मल्टी प्रोसेसर एंड मल्टी कोर आर्किटेक्चर, मोबाइल आर्किटेक्चर। दिस इज इट फॉर यूनिट 1। तो यूनिट 1 का हम देखते हैं क्या है। व्हाट इज CPU? द CPU सेंट्रल प्रोसेसिंग यूनिट इज लाइक द ब्रेन ऑफ द कंप्यूटर। एक काम करते हैं, नोटबुक रखते हैं साथ में, ताकि अगर मुझे लगे कि कुछ पॉइंट लिख के रखने से अच्छा होगा। पढ़ते पढ़ते अगर लिख कर रखे ना तो वो दिमाग में ज़्यादा रहेगा। ओके, तो what is the CPU? The CPU is the brain of the computer. It executes instructions, step-by-step program and process data stored in a computer main memory. मेन पार्ट ऑफ द CPU का मेन पार्ट में आता है रजिस्टर, ALU, कंट्रोल यूनिट। रजिस्टर में क्या है कि स्मॉल फास्ट मेमोरी इनसाइड द CPU and store instruction being executed, addresses like location of data, actual data, and okay, arithmetic logical unit, ALU does arithmetic logical unit. अरिथमेटिक का बात आ रहा है, मीन्स कैलकुलेशंस। It does all the calculation and logical operations like addition, subtractions, and or not. These are control unit. Control unit controls how instructions are fetched, understood, and executed. Manages movement of data between memory, register, and ALU. Control unit. The control unit is a part of CPU that acts like a manager or controller. Control unit is a part of the CPU that acts like a manager or controller. The controls and coordinates how instructions are carried out by computer. Registers are very fast temporally memory unit inside the CPU. They are used to store intermediate results and help speed of the CPU performance during tasks like arithmetic, logical operation, data operation. Data path. Data path. A computer uses many components to execute instruction. A computer uses many components to execute instruction, but how does data and instruction move between these components? The movement is done through data path. Two type of data path: internal data path or external data path. The data path moving data within the CPU. Internal data path moving data within the CPU. They transfer data from one register to another register. Data between ALU and register, control unit, which is used by the control unit. The internal movement happen using local buses which carries data, control signals, instruction, addresses. External data path outside CPU. These move data between CPU and memory or IO device. This is done using a special circuit called a system bus. Example from the text: at the start of each command circle, the program counter holds the data of the next instruction. The address is transferred to the memory address register. This register can be done using a dedicated data path between PC and MCR. Imagine a kitchen where cooking happens. Internal data path is passing ingredients between drawers and shelf. External data path is like bringing groceries from the store to the kitchen using a delivery cart. This is what system bus is. A direct path from the fridge to the stove helps you cook faster, just like a dedicated data path in the CPU. Control unit. The control unit is the main part of the CPU that controls and manages how all parts of the computer work together. Sends control signal to the unit to tell what to do and when. What does the control unit do? Give command to memory ALU input. What does control unit do? Control unit give commands to memory ALU input output devices. Control bus data flow inside the CPU between control data flow inside the CPU between CPU and memory, between CPU and input devices. Follows a sequence. This control unit works usually clock pulses generated by the system clock. These pulses like steps. Each time a specific control signal is sent to the perform a command. In simple terms, the control unit is like a traffic controller in a city. It directs traffic, controls signals to allow movement at the right time, and makes sure everything flows smoothly. Okay, what's memory unit then? A memory is a memory. The memory in a computer store data and instruction. Computer store information in binary digits 0 and 1, which are called bits. A group of 8 bits is called a byte. But today we often store large data like 2 bytes 16 bits, 4 byte 32 bits, 8 byte 64 bits, etc. Memory size units: 1 KB is this, 1 MB 1024 KB. Yeah. Why memory is important? The main job of memory is to store program instruction related data. These instructions are fetched by a CPU for execution. This type of memory is usually called RAM, random access memory, because the CPU can access any memory location directly. IO devices, input devices are used. Okay, यहाँ थे IO devices. Input devices are used to enter data or program into the computer. Example: keyboard. Modern computer use pointing devices and screens to select options in GUI, graphical interface like Windows. Output devices shows result of the program. Example: monitor or printer. Monitor shows the result on a screen. Printer give a hard copy. Printer version. Memory store instruction and data. Input device let us give data to the computer. Output device let us see the result. What is instructions? While studying the CPU, one term keeps coming up: instruction. In simple terms, when you write a program in the languages like C, Python, Java, or C++, that program must be compiled, converted into machine language, linked with libraries, and loaded into memory of the computer. After this, the program becomes a set of binary instructions that work on binary data. Common high-level instructions include arithmetic like plus and minus, decision making like if and else, loops like while, for, function, procedure calls. Finally, final summary: an instruction is a binary command that tells CPU what to do with which data and where to store the result. It may also tell the CPU to jump to a new part of the program. How are instruction executed? To understand how a computer execute instruction, let's take a simple example from a high level language like C. int x 10 y okay, x में 10 है, y में असाइन करते हैं 5 एंड z हैज़ नॉट z को कुछ असाइन नहीं है, बट x और y का डेटा z में असाइन कर रहे हैं. What happens step by step? This line creates 3 memory location for variable x, y and z, which is, yes, this is true कि x, y and z three memory location for variables, 3 memory location for variable x, y and z. It store the value x in 10 in x, 5 in y, and reserves the spaces for z. These variables are stored in memory with their own unique address. Instruction execution, this line is an arithmetical operation. The compiler will translate this high level instruction into machine. The machine instruction includes OP code for addition, the addresses for x and y where value 10 and 5 are stored, the addresses of z where the result will be saved. Okay. Inside the CPU, the values of x and y are brought to ALU input register. The ALU perform the addition. 10 plus 5 will be 15, and the result 15 is stored in the ALU output register. Finally, the result is sent back to the memory into the location reserved for Z. This whole process follows the cycle. Fetch the instruction from memory, decode it to understand the operations, execute it using ALU. This is called the fetch, decode, execute circle. Fetch, decode, execute circle means, and it happens for each instruction. Fetch the instruction from the memory, decode to understand the operation, execute it using ALU, arithmetic logical unit. Each instruction and variable has a binary format in memory. Done. Summary: allocates memory for variable, translate high level instruction to machine languages, uses ALU to process data, and stores the result back in the memory. How instructions are executed? Variable like x, y and z are stored in the memory with values. This statement x equal to xyz is converted by the compiler into machine instruction binary form. CPU fetches instruction, decode, execute the इतना हो गया. Instruction cycle. So fetch, the CPU gets the next instruction from the memory using the program counter and store it in the instruction register. Okay, the CPU get the next instruction from the memory using the PC program counter. CPU get the instruction from memory using the PC and store it in the instruction register. Decode, the CPU understands what the instruction means by decoding the operation code. OP code means operation code. Read operands, the CPU fetch the data needs for the instructions from memory. Execute, the CPU perform the operations using ALU and store the result. Okay, can the program be interrupted? Okay, can the program be interrupted? Yes, during execution the program can be stopped due to error or IO events like keyboard or the desk input output. Interrupt, an interrupt is a hardware or software signal. Interrupt is a hardware or software signal that tells the computer to pause when it's doing and handle something urgent, like input from keyboard or error or a timer. In computer, an interrupt happens when something unexpected or urgent occurs during a program execution, but the current instruction is completed first, and then the CPU responds to the interrupt. Example: you are trying and CPU is calculating something. Oh, no, you are typing and computer is calculating something. Suddenly a key pressed from the input, so the CPU interrupts its task to handle your key press. By mistakenly the press key, we press any key, and then on the background, if something calculate, CPU is calculating something, then it's get interrupt. Okay, think of interrupt as an emergency alert that stop current work and focus on something important. How CPU handles interrupts. CPU's current instruction completes, no interrupt in the middle of it. CPU pause the current program and remember its state. Okay, CPU finds why the interrupt happened. CPU runs a special program called interrupt service routine to handle the event. Once the event is handled, the CPU goes back to the pause program and continues from where it left off. Computer architecture. Now, computer architecture. Okay, let me check the PDF once. Okay, various computer architecture. What the architecture means in the term of computer. तो पहले ये पढ़ते हैं कंप्यूटर आर्किटेक्चर, द डिज़ाइन और ब्लूप्रिंट ऑफ हाउ अ कंप्यूटर works, computer system work. We can say that the design or blueprint of a computer of how a computer system work, how different part of the computer like CPU, memory, input output are built and how they work together. Example using okay, the paragraph compares computer architecture to design for a building. Just like building a design according to the needs of people who will use them. Example office, house, hospital. Similarly, a computer is designed to meet the needs of users like speed, cost, size. These. How is computer designed? First, the design is made like on paper. This is architecture. Then it built using transistors and circuits. This is hardware. Once hardware is built, it is tested and then used. How a computer evaluated performance, cost, efficiency, readability, compatibility with software. Can it run the software easily or not? Now the type of architecture, von Neumann architecture, very important. ये आ सकता है, तो ये देखते हैं. Simple explanation for beginners, right? This is a type of computer design made by a scientist named John von Neumann. Okay, so the von Neumann architecture is designed by a scientist named John von Neumann. Many modern computers are still based on this design. So, what are the main parts? Think of a computer like a working kitchen. All right. तो von Neumann architecture का समझने के लिए think of a computer like a working kitchen. ये मैं थोड़ा I just want to take few terms. कुछ नोट करती हूँ मैं यहाँ से. What I von Neumann से related. von Neumann architecture. ठीक है. First of all, ये designed by a scientist named John von Neumann. ठीक है. Many modern computers are still based on this design. Okay. The main part. What are the main part? So think of the computer like a working kitchen. Working kitchen. CPU, central processing unit, the CEF. Okay. Then memory unit. Memory unit is like a fridge or pantry. Memory unit is like a fridge or pantry. Store both the ingredients, data and instructions. Okay. Data and instructions are stored here in a memory unit. It's like a CEF. It follows instruction and process of the data. ठीक है. CEF follows instruction and data, processes of data. and the data and instruction stores where? In the memory unit. Input devices. Okay, next, input devices, like you telling the chef what to cook, keyboard and mouse. Input devices. Hmm. Okay. Okay. Next, output devices, which what we are receiving, what you're receiving. Okay. Output devices, like you're receiving the disk from the chef, and the connection, output devices. And उसके बाद है connections, means buses, the kitchen pathway and pipes, buses के अंदर we have address bus, data bus and control. Address, data and control. Address, where to go, address bus, where to go. Data carries the actual item, and the control bus means tell what to do. And ये है what to do. That's it. How does it work? The program, list of instruction and data both are stored in the same memory. CPU reads the instruction and data from the memory unit. It processes the data using those instructions, then sends results to the memory or output device. What's the special about von Neumann architecture? It uses one memory for both instruction and data. This is called the Princeton architecture. Okay. It's simple and cheaper to build, but CPU has to wait if it is reading an instruction and needs data at the same time. Von Neumann architecture. John von Neumann developed this computer architecture. Most computers today are based on this model. The main parts of the von Neumann architecture are CPU, memory unit, input device, output device, and the buses. There are the communication line to carries address, data, and control. In this architecture, same memory is used for the base instruction. Same memory is used for both instruction and data. The CPU reads the instruction from the memory and execute them. Input is taken from input devices and output if given through output devices, right? तो वॉन न्यूमन का आर्किटेक्चर कैसा है? कंट्रोल यूनिट, लॉजिक यूनिट, मेमोरी यूनिट, इनपुट एंड आउटपुट. ओके. नेक्स्ट, द मोस्ट इम्पॉर्टेंट आई कैन से, हार्डवेयर आर्किटेक्चर. वॉन न्यूमन आर्किटेक्चर समझ में आ गया. नेक्स्ट है हार्डवेयर आर्किटेक्चर. ओके. ALU, इंस्ट्रक्शन मेमोरी, डेटा मेमोरी, कंट्रोल यूनिट एंड IO. लेट्स सी क्या है इसमें. Hardware architecture is a computer design where instruction and data are kept in the different memory. Okay. Von Neumann में क्या था कि data and instruction are kept in the same memory, but in hardware architecture is telling that instruction and data are kept in the different memory places. Think of it like, imagine you have a notebook for recipes and a basket of ingredients. A notebook or a basket of ingredients, which is data. You can read the recipe from the notebook while picking the ingredients from the basket at the same time. It means you work faster than. That's a hardware architecture. Two memories, one instruction, two memories, one for instruction, one for data. Faster work. CPU can read instruction and data together. Separate buses, like two roads, one recipes for and one for ingredients. Used in small devices, audio tools. It is harder to design but faster. Why use it? Because it allows computer to do two things at once: read instruction, use data. This saves time and improve performance. Real life example. Let's say you are cooking. You look at the recipe instruction book and grab ingredients, data, memory at the same time. This is better than watching one to finish before starting to another. Final summary: hardware architecture, separate memory for instruction, helps CPU to work faster, ठीक है, commonly used in microcontroller, audio video devices. What the instruction set architecture? What is instruction set architecture? IS is like a rule book for the CPU. It tells the CPU what it should be able to do, like a list of tasks, instruction it can understand and perform. Think of it like this. Imagine you have a robot. ISA, the language or command you teach the robot. The language and command you teach the robot, like walk, fix, stop. CPU, the robot brain that follows this command. Micro architecture, how the robot is built inside to follow those commands. Easy way to remember. ISA, instruction set architecture, a set of instruction of a CPU understand. Maybe some different type of a different language. CPU ignores how the CPU is built. Instruction type, arithmetic, data transfer, branch and jump. Instruction format, how instructions are written or coded. Different ways of writing instruction. Why difference in ISA and microarchitecture? ISA stays the same, so software work on many types of hardware. Microarchitecture can change but still follows ISA rule. This helps run the same program on different machines. Visual explanation is got. Set of instruction the CPU understand like language. Set of instruction that CPU understand. Doesn't care how the CPU is built. Help make software compatible across devices. Different machine can follow. Example ARM MIPS. ठीक है. RISC and CISC. Simple instruction, fast speed, more work to compile. And complex, simple. And CISC complex instruction, slower speed, more work to for hardware. Risk to better mobile devices efficiency. Piping many register and load stores. What is risk? Risk, reduce instruction set computer. Risk, reduced instruction set computer. ARM processor, like the ones in a smartphone. Main idea. RISC uses simple command that the CPU can execute. RISC uses simple command that the CPU can execute very fast, often in one clock cycle. This makes the hardware simpler. Because the hardware is simple, the compiler has to do more. RISC versus CISC. ठीक है, इसमें क्या है देख लेते हैं. Simple instruction, fast speed, more work for compiler. Or CISC, complex instruction, slower speed, more work for hardware. RISC is better for mobile devices because faster and energy efficient. Piping many register and load store method. Key RISC feature. Real life example, cooking Maggi noodles. Imagine this, you want to make Maggi noodles. Let's compare RISC versus CISC. If there is a both safe. Safe RISC, simple step, fast execution. RISC safe has a recipe with small clear steps. Boil water, add noodle, add taste maker, stir for 2 minutes, serve. Each step is simple. RISC. Each step of simple takes less time and can be done quickly in the order like pipeline next system. Risk is taken example. Risk the Maggi noodles. Maggi noodles. Fast execution needs more step, but everything is fast and simple. Ceph one big complex step. Cisc use one big complex instruction, cooking Maggie completely. But this takes more time because the chef has to do everything in one go. Boil, add noodles, cheese, tastemaker all hidden in one line. It's harder for the chef even if the fewer steps. Cisc style. One complex instruction takes more time for per execution. Hardware does more work. Why is risk better sometimes? Because mobile devices need fast and powerful efficient system. Risk works well with the high cooked speed like chef risk. Hmm. Easier to keep everything simple and fast. How this links to computer. Chef follows recipe, CPU follows instruction. Simple and step by risk instruction. Complex CISC instruction do many small steps. Risk pipelining. Use bowls to store ingredients, register stored data. Quick summary. Risk simple, fast, efficient like self risk making Maggie step by step. CISC one big step, slower, complex like self CISC doing all at once. Mobile architecture. What does this mean? Mobile phone today are not just for calling. They work like mini computers. They can run many apps, chatting, editing, games, store large data, work fast and smoothly. So videos, news and more. Mobile, a mini computer, computer input output touch screen, input unit touch screen, keyboard and CPU, mobile CPU, output unit screen, speakers, camera. What's inside the mobile CPU? The CPU means brain of the mobile is divided into two parts: communication processing unit and application processing unit. Handles calling, texting and network and hardware, games and etc. Other functional unit: display management, shows screen properly, management store data and apps, power saves battery, data management handles battery. Diagram idea this. Key points to remember: for example, mobile phone is now like mini computer. Mobile as input unit, touch, CPU unit, screen, and output unit. Mobile CPU is two-part: communication process, calls and network, communication process, apps and tasks. Each parts manage display. Okay. Multiprocessor and multi-core architecture. Multiprocessor, a computer system with more than one separate processor, CPU clips. Multi-core, a multiprocessor, a computer system with more than one separate processor. A single processor that has multiple cores. Multi-cores, a single processor that has multiple cores. Many CPUs inside is multiple cores. Main idea: both allow parallel processing, meaning they can do many tasks at the same time. Multiprocessor, many CPU, multi-core, one CPU with many cores. मल्टीप्रोसेसर मैनी सीपीयू. एक मिनट, ये भी मुझे लिख लेना चाहिए. मल्टीप्रोसेसर many CPUs and multi-core one CPU with many cores. Think of a kitchen multiprocessor. You have three steps in a separate kitchen. Each step cook a one dish at a time independently. Multi-core, you have one big kitchen with three steps, three core working together. The different counters still cooking three dishes at once, but inside one kitchen. Tips to remember: multiprocessor, multi CPU, separate clips, multi-core, multi-step inside the CPU, multiprocessor, a multi-core architecture. Short exam friendly answer. Multiprocessor architecture. A multiprocessor system has more than one multiprocessor CPU has more than one separate processor. These processors can perform different tasks at the same time, which increase the system speed. If all processors are the same and share memory and operating system, it's called symmetric multiprocessing. Multi-core architecture. A multi-core system has one processor. A multi-core system has one processor with multiple cores inside it. Each core can work on a separate task. For example, a quad-core processor has 4 cores. Main difference: multiprocessor, many separate CPUs; multi-core, only CPU with many cores. Both support parallel processing and belong to MIMD inference classification. ब्लॉक 2 में डेटा रिप्रेजेंटेशन का है, ब्लॉक 3 करते हैं। लॉजिक गेट्स का कुछ है। Boolean algebra, logic circuits, adder, decoder, multiplexer, encoder, program logic, read-only memory. Logic gates. A computer system work using binary numbers, only 0 and 1. Logic gates. A computer system works using binary numbers, only 0 and 1. Zero or 1. The calculation and decision in computer are doing using electronic circuits. Okay, the decision in a computer are doing using electronic circuits made up of transistors. These circuits are called logic gates. A logic gate is a small electronic circuit that takes input 0 or 1 and give output in a 0 or 1. ठीक है, depending on the type of gate. Logic gates का बात जब भी करें तो is a computer system using binary number which is 0 and 1. A computer system works using binary number 0 and 1. All the calculation and decision in a computer are done using electric circuit made up of transistors. These circuits are called logic gates. What is a logic gates then? A logic gates is a small electronic circuits that take input and give as an output. and input be 0 and 1 and output is also 0 and 1 depending on the type of gate. The logic gates are used to perform basic operation in computer like arithmetic, addition, logic and control decision it turning into on and off. Each gate follows a truth table that shows all possible input and output combinations. How it works: input 0 and 1 gate checks the inputs, give the output into 0 and 1. For example, AND gates, OR gates and NOT gates give output 1 only if the both input is 1. AND के केस में gives output 1 only if both inputs are 1. OR gates give output if one is if any input is 1. Okay, not reverse the input 0 become 1 and 1 become 0. A real example to be remembered easily: if the door opens only if you and your friend, okay, AND gates, the door open only if you and your friend both have keys. Okay, OR gates, the door open if you or your friend has key. फर्स्ट में बोथ शुड हैव की एंड सेकंड और के केस में इफ एनी वन हैज़ की देन इट इज़ फाइन, द डोर विल बी ओपन. Yes, not gate, the door opens only if the no key is inserted. Okay, when the key is not inserted then the door open. If the key inserted then door will not be open. This is what not gate. How to write an exam? Logic gates. A logic gates in an electric circuit is used in computer to perform operation on binary data. It takes one or more input and produce a single input based on the Boolean logic. Logic gates are built using transistor, are more used in implement basic functions like AND or NOT. This gate is represented by a symbol and works according to the truth table that shows how output depends on input. Logic gates are the building gates of digital circuits and helps perform the arithmetic, logical and control operation in a computer. So we are talking about the transistor all the time. Then what transition is meaning? Let's check it out कि क्या है. A transistor is a tiny electronic switch used inside computer and digital devices. Okay, a transistor is a tiny electronic circuit is used inside computer and digital devices. It can turn on or off the flow of electricity. In simple words, the transistor controls current just like a tap controls water. It can be in two states, on and off. Current flows represent 1 and current flows not flow means represents 0. Why is it important? Computer understand only 0 and 1. Transistor helps store and process these 0 and 1s. Millions and billions of transistors are used in processors, memory and logic gates. Easy way to remember: the switch is on, switch on, light glows, 1, switch off, light off, 0. Just like that transition switch electricity to represent data. Exam definition: a transition is a small electronic component that work like a switch control the flow of the electricity. It is the basic building blocks of the digital circuits and is used to represent binary values computer. Oh, that's it? नहीं, यह हुआ. नेक्स्ट यहाँ पे देख लेते हैं कि गेट्स का कैसे है. नॉट और लॉजिक गेट्स. ठीक है, ट्रूथ टेबल में क्या आ रहा है? Okay, so what is I and F? I represent input values and F represent output values. Not के केस में है I input and output 0 1 1 0. It's simply inverted. Boolean algebra explains simply. What is Boolean algebra? Boolean algebra is a type of math that works with only two values, 0 and 1. It is used in computer to make decision using logic. This was created by mathematician named Gauss Pauli in the 1800. Where is it used? Inside computer, in logic gates, in digital circuit, in solving logic problem. Basically, where computer need to decide something using 0 and 1 Boolean algebra is used. How it works? How it works? It use logical operation like operation and or not, true only if both are true, or true if any one is true. Real life example: imagine if you decide to go out, it is sunny and you have free time, then if it is sunny and you have free time, then you go out. This is and condition. If sunny or you are bored, then you go out. This is our condition. If you're not running, you'll go out. The Boolean logic in real life. How to write an example? Boolean algebra. Boolean algebra is a mathematical system that works on binary variables 0 and 1. It was developed by George Boole in 19th century. In Boolean algebra, 0 equal to false and 1 equal to true. This is used to design logic gates and digital circuits. Boolean algebra are uses operations like and or not. Logic circuits. Logic circuits. Logic circuit is an electronic circuit used to perform operation on binary input 0 and 1. It is built using logic gates like and or not. If logic circuits follows Boolean operation, which tells how to combine the input using logic gates. Example: if Boolean function digital circuit Boolean algebra use operation 0 और मैं प्लस एंड में डॉट and this and or Karnaugh map. A Karnaugh map is a graphical method used to simplify Boolean expression. It helps reduce the number of logic gates in the circuit. K-map are used to uncheck variable. Each cell in a K-map represents a minterm combination of input. By grouping first in the K-map, we create a simple Boolean function. It helps in design efficient digital circuits. Combinational circuits में क्या है? Adder, adder or combinational circuit used to perform binary addition. Half adder adds 2 bit A and B. Output sum and carry does not carry. In full adder adds 3 bit. Half adder adds 2 bit and full adder adds 3 bit. Decoder. A decoder is a combinational circuit that converts binary input into a specific output. Decoder. Multiplexer. A multiplexer is a combinational circuit that select one or many input line and forward it to a single output line. Encoder. An encoder is a combinational circuit that converts active input into a binary code. Read-only memory. Read-only memory is a non-volatile memory to store fixed data. It is used combinational circuits and a decoder to provide output. It is a permanently stored and cannot be modified during the normal use. It remains data even after power failure. Unit 4. Sequential circuit. A sequential circuit is a combination of combinatorial logical memory element. It can store data and its output depends on both current inputs, previous state. Components: combinational circuit, flip-flop storage, clock pulse. Synchronous and asynchronous. State changes with clock pulse. State changes without clock. It may be unstable. Used in counters, register, traffic lights, etc. Real life example: think of a traffic light system. It changes light in a sequence. It remembers the current state using memory timer. Basic components: combinatorial circuits does combinational circuit does the logic like and or flip flop store binary data like memory. Clock pulse, a timing signal that control with flip flop update. Flip flop decide the current state of the circuit. Combinational circuit does the logic like and or flip flop store binary data like memory. Clock pulse, a timing signal that control with flip flop update. A flip flop decide the current state of the circuit. Latches and flip flop. What is latch? A latch is a basic memory device. It is sequential circuit that can store one bit 0 and 1. It keeps its value until something charges the input. It does not use a clock respond immediately when input. एक बार फिर से देखते हैं. What is latch? A latch is a basic memory device. It is sequential circuit that can store one bit. ठीक है. It keeps its value until something changes the input. It does not use a clock respond immediately when input changes. Think a latch like a light switch. Once turned on, it stays on until you turn it off. Okay. A latch is a basic memory device. It is a sequential circuit that can store one bit. It keeps its value until something changes the input. It does use a clock. Think of latch switch light. Once it on, it is still on. Latches. What is flip flop then? A flip flop is built using latches. Latches is a basic memory device. And flip flop is built using latches. It is also used to store one bit, but with timing control, it changes state with a clock signal arrives. It makes flip flop more reliable in a digital system. Flip flop is like a timer control switch. It changes only when the clock ticks. Latch and flop क्या है? A sequential circuit that stores one bit of data and does not use a clock, simple and responds to input immediately. Built using latches, store one bit of data, works with clock views so it's more reliable. Flip flop are commonly used in register, memory, and counters. Okay. Master slave flip flop. What is it? A master slave flip flop is made using two flip flops. One is called the master and the another is slave. It is used to avoid problems like race condition where output keeps changing rapidly. How it works? Step. When clock is equal to 1 means on, the master flip flop get active. It check the input S and R and update the state. Slave does nothing because it gets the inverted clock. When clock is 0 off, the master stops keep its output fixing. Now the slave becomes active and copies the output of the master. So both master and slave update only once per clock cycle with avoids errors. Master slave flip flop. A master slave flip flop is made using the two flip flop master and slave is avoid output problem by working into a step. Step 1, clock 1. Master become active and updated state. Slave is inactive. Slave becomes active. Master is inactive. Output changes only once per clock cycle, making it stable. Think of a register like a small locker box with separate section. Each flip-flop is a locker storing one bit. You can think of a register like a small locker box with separate section. Load all items at once. Shift. Register sequential circuit. A register is a storage device made using flip-flop. A store binary data temporarily inside the CPU. To store the bits, we use flip-flop. Operations. Parallel load all bits into a register at once. Shift move bits left to right. Use operation like multiplication. Counters. What is counter? A counter is a sequential circuits that produce output in a specific sequence. Each time it receives a plus, counter helps keep track of the steps like counting the number of instruction executed. Type of counter. एक बार फिर से देखते हैं. A counter is a sequential circuits that produce output in a specific sequence. Each time it receives a plus pulse. Types of counter. Asynchronous counter, ribbon counter, flip-flop change their state one after another. Output changes not at the same time. Synchronous counter. A flip-flop changes their state at the same time, synchronized with the clock. Real life example. Think of a step counter in a fitness watch. It counts your step one by one like asynchronous counter. Or a traffic light timer where multiple signals changes simultaneously like synchronous counter. Counters are sequential circuits that generate output sequence based on the input pulse. They are used to count event and keep track of sequence during instruction execution. Type of counter: asynchronous counter, flip-flop change states one after another. Synchronous counter: all flip-flop change states simultaneously with the clock pulse. Random access memory: random RAM is a temporary storage device used in computer to store binary data. RAM is a temporary storage device used in computer to store binary data. It is made up of flip-flop, which are where each flip-flop stores one bit. RAM allows two main operations: reading and writing. Reading involves using a decoder to select the memory cell to retrieve data. RAM allows two operations: reading and writing. Reading involves using a decoder to select the memory cells to receive data. Writing involves selecting a memory cell when changing a stored data. RAM provides fast access to any memory location, enabling quick data retrieval and updates. RAM provides fast access to any memory location, enabling quick data retrieval and updates. Writing involves selecting a memory cells and charging its stored data. इसमें क्या कहता है? Sequential circuits, latches and flip flop, master slave flip flop, registers, sequential circuits, counters and RAM. okay? तो ब्लॉक वन का यूनिट 1, 3 और 4 हो गया. नेक्स्ट ब्लॉक 2 को से कंटिन्यू करेंगे. इसको भी और अच्छे से अभी जस्ट थोड़ा समझ में आया, इसको और अच्छे से पढ़ना पड़ेगा. और अभी तो जस्ट एक काइंड ऑफ समझने के लिए एनालॉजी से एग्जांपल से समझ रहे थे. एग्ज़ाम में थोड़ा टेक्निकल वर्ड्स यूज़ करके अच्छे से लिखना पड़ेगा, तो उसके लिए कुछ द प्रॉपर डेफिनेशंस हमको पढ़ना पड़ेगा अच्छे से. सो दैट्स इट.